Okay, hello everyone. So welcome to lecture 3. So today what we'll do is we shall solve problems on that is change of variables, right? So let me have a glance. That is, this is change of variables. So let me have a glance. In my previous class, we have gone through all these problems, and as I said, that at any instant, if you have any problem, so you can contact me for the solution, or you can send a message for the solution, right? So it was a change of variables, right? Sorry, it was evaluation of change of order of integration, right? Now what are we doing is, now the next concept is, so all these problems are over, right? It is change of variable. Now what happens in double integral, that is, okay, at any instant there is a problem given in terms of f is a function of x and variable y with respect to dx and dy. So what we do is, whenever the problem is complicated, so what we can do is, the best possible thing is we can either change it to some variable. So our evaluation of this double integral can be done very easily. So we can change it to some variables, right? Fine. A coordinate system in terms of x and y can be converted into a polar coordinate in terms of r and theta, and finally we get the area of that given region. So these are the tools and techniques, you can say, right? So here it is, sometimes it so happens that the double integral can be evaluated easily by changing the variables. Now this is a coordinate system with that is points, that is x and y, and here the given function is in terms of r and theta, right? So x is equal to r cos theta and y is equal to, that is, r sin theta. So let me go back to the previous concept that you have already studied. So this is a polar coordinate system and a Cartesian coordinate system. See here, in a polar that is Cartesian coordinate system, what we exactly do is, given a point P, so it is from x, sorry, this is y, and at a distance x. So any point here can be represented, that is x and y. So this is called as coordinate system, that is any point in a Cartesian that is coordinate system. Also, given a radial vector along with theta, the point will be represented by r and theta. Now it so happens that any given coordinate system, sorry, I will draw this figure. So any point here, it is p x comma y. So any polar, and that is Cartesian coordinate, can be transformed into a polar coordinate, and any polar coordinate can be transformed into, that is, Cartesian coordinate, right? So this is what you have studied in your polar equation, that is polar coordinate system, right? And then see here, let xy be the Cartesian coordinate of the point P, then we can find, see, this is r, so obviously by Pythagoras then this turns out to be x square plus y square, that is square root. So is it not r is okay, r, okay, and theta is, okay, so tan theta is what? It is y by x. Therefore what will be happen to theta? So theta will be tan inverse of y by x. Now see here, what is cos theta? Cos theta is nothing but x by r. Therefore x can be written as r cos theta. And what is sin theta? Sin theta is nothing but y by r, right? So what is y? It is r sin theta. So these are the two equations, and what you can see is, see, this r and theta can be transformed into x and y, see here, and x and x is in terms of r and theta, and y is in terms of r and theta. Now here, this is all basics what I am telling you, so that none of the student should be unaware of the concept, right? So what is polar coordinate, how are we changing it from polar to that is coordinate, and coordinate to polar. So this is just an explanation. At any instant, if you already know this concept, then you can skip the video to the problem domain. Now relation 1 enables us to find polar coordinates in terms of r and theta when the Cartesian coordinates x and y are known. Conversely, this relation 2 enables us to find the Cartesian coordinate when the polar coordinates are known. So usually the Cartesian form is always represented by y is equal to f of x, and polar form is represented by that is r is equal to f of theta. Now let me go back to my problem, right? So let us have geometrical interpretation. So what are we doing in double and triple integral? See here, this is a Cartesian, this is along x and this is along y. So if I take horizontal and vertical strip, and if I take some part of this coordinate system, so this is some part dx and this is some part dy, and this is a, b, c, d are the points. Now similarly, the polar coordinate, see here, this is a radial vector r, right? Okay, and this is some part of dt, and this is the angle subtended. Okay, so it is r theta. Now this here it is p, q, r and s, and this is some part of r, that is dr, right? Okay, now this is p, q, r, s, and this is angle subtended. So this is r theta, this is some portion of r, that is the radial vector. So this is some, that is dr. Now see here, whenever if I want to change this from Cartesian to polar form, I can write it as r is equal to r cos theta, that is x is equal to r cos theta, and y is equal to r sin theta. Therefore the area of the given small section of this area a, b, c, d is dx dy, right? So it is some dx dy, and area of this given area, that is p, q, r, s, will be r dr by dr into d theta. Therefore which implies, so when the transformation is taken place, so this dx dy can be written as r dr by dr d theta. So dx dy can be written as, whenever we are changing the variable for double integral, that is x and y, right? Now just like another that is substitution. Now for single integration, right, what you people used to do, that is for single integration with respect to f of x and dx, okay, over the limit a and b, right? So you want to convert this variable, that is x, in terms of t. So what you used to do, that is 3 steps, that is writing x in terms of t and dx, that is writing, first step is writing x in terms of t, right, and dx in terms of, that is dt, and finally new limit for t. So with respect to this equation, you will find new limit for t. Same is the case whenever we are changing the variables from x and to theta. So okay, similarly what are we trying to do is that is in the same manner, that is we are trying to take, that is any integral, that is double integral over the region r, f of, that is f of x comma y dx dy. So after transformation, that is change of variables, that is double integral over f in terms of r theta, and one more thing we have, that is r d theta by, or d theta dr, or dr d theta, right? And also the limiting values are also changed, so this becomes r1, right? Okay, fine. Now see here, now let us see certain cases. How does this transformation takes place over certain functions? So let me have one of the form, or you can say a type, right? So any given for variable x expressed in terms of that is some other variable, that is u and v, and y is a variable expressed in terms of u and v. Then if I want to transform x in terms of uv, then and the Jacobian of this transformation can be done by, that is dou u by dou v by dou xy. I hope there is certain changes over here. So let me this is not correct. So here it is x, here it is y, here it is u, here it is v. Now what do you mean by this Jacobian? So Jacobian is nothing but it is an application of the Jacobian is used for significant evaluation of double integral, right? So it is usually used for evaluation of that is double integrals of the form f of xy over double integral and triple integral as well, by transformation of, this is important, one system set of coordinates to other, right? So only this thing you need to know, and in your previous classes also see it. This is one of the definition, that is how it is being explained. Suppose if you have u and v be a functions of two independent variables x and y, the Jacobian of u and v with respect to x and y, symbolically it is represented as j u v by xy. So here the transformation is taking place of variables is taking place from u to v, and this is how we take its determinant. And now going back to our concept, if any given variable is expressed in terms of u and v and y is expressed in terms of u and v, then the Jacobian of this transformation from x to v will be determinant of dou x dou u, dou x dou v, dou y dou u, dou y dou u, and provided that the determinant of this Jacobian is not equal to 0. So given a function that is in terms of x and y over a region, and when we transform it to phi of uv and also changing the limits, new limits over, that is this dx dy will turn out to be Jacobian of dou u dou v, whatever is the Jacobian. Okay, now this is one of the case. Now one more case which I was discussing earlier. If x is a function in terms of r and theta and y is a function in terms of r and theta, then the Jacobian, that is the transformation of x y in terms of r and theta, is given by Jacobian of dou x dou r, dou x dou theta, dou y dou r, dou y dou theta, which is equal to cos theta sin theta minus r sin theta, that is partially differentiation with r theta, which will, after taking its determinant, this turns out to be r. Therefore the given after change of variable from f of x to f of r theta, right? So r changes to, with given new limits, that it changes to r1, this given region r, and dx dy it changes to r dr d theta, which I have also explained in the above concept, right? Now let me come to the concept, and the concept is okay, fine, we shall start with the example. So you know how to change the variables, whether it is given in some variable, that is the given function is in terms of x and y, so you can convert it into r and theta, or if the given function is expressed in terms of u and v, and then you can and y is also expressed in terms of u and v, then change the variables and take the Jacobian and then evaluate it, right? Okay, fine. Okay, let me start with the example. Okay, so this time the example is given as, that is evaluate by changing into, that is polar coordinate. You have been asked to change into that is polar coordinate, right? Now first thing is, the given integral is given by, that is the function, that is y square root of x square plus y square dx dy. So this is a function of the type, that is f is a function of x and y, and you need to change or transfer it to, that is in terms of f is a function of r and theta, right? So, and what are the limiting values? That is x equal to 0 to square root of a square minus y square, and y is equal to that is 0 to a, right? So let me consider, that is, let I is equal to, that is integration, double integration over the limit x equal to 0 to that is square root of a square minus y square, and y is equal to 0 to a, and the given function is y square root of dx square root of x square plus y square dx dy. Okay, now if I want to change this in terms of polar coordinate, the very first step is you write this given particular things which are already told to you, that our polar coordinate can be transformed into Cartesian coordinate can be transformed into polar coordinate. So let x equal to r cos theta, which you already know, and y is equal to r sin theta, and the Jacobian obviously is equal to r, so you need not write it, you can write this directly. Okay, fine. Now the region of integration is bounded by the curves. So the very first thing is you should always have the habit of drawing a rough sketch, right? So here in the notes, okay, fine. So here the region of integration R is bounded by the curves, that is y is equal to 0 and y is equal to 0. So in notes, please make this correction as a, right? Okay, so y is equal to 0 and y is equal to a, and x equal to 0 to x equal to square root of a square plus y square. Now the value of x is equal to 0, so it is 0, and value of x is equal to a square plus y square. So what is this equation? This equation is nothing but, see here, this is x is equal to, it is square root of let me pause the video because I am short of okay, fine. So this is x is equal to that is where is it, a square minus y square, right? Now what I do is I take this square root sign here, so it becomes x square, this minus y square, I will take this, so I will get this particular equation. So this I have already said in my lecture 2, that giving standard this is a standard equation of circle, so that is x square plus y square is equal to a square. This in fact is, first thing is you draw this circle, right? I'm not that good at drawing because my writing pad is not working properly, so kindly pardon excuse me for this. So first thing is you draw a rough sketch, right? Now this is the value for x is equal to 0 and the equation, right? So yeah, then y is equal to 0 to a. See here, see y is ranging from 0 to a. Also you need to find the common region where to which you need to find your area, right? So common region, so it is y is ranging from, that is 0 to a. Since I have already drawn this graph, so this is what I am doing it for you again. So what is this region? I do not include it, right? Because my common region is, with respect to this limiting points, my common region is this, right? So it so happens now it is nothing but, that is, now I need to find the new limits and change the variable. Now what is happening to theta? See here, if you see this rough sketch, so what is happening to theta? So theta is moving from what it is moving from, that is, this is the value that wherein y is equal to, that is, here it is 0. So theta is moving from, that is 0 to, and this will be your 90 degrees. So theta varies from what, that is 0 to pi by 2. Now see here, r is the distance from the origin to the point. So how do you calculate this r? So r, that is, r varies. How do r vary? R varies from, now please pay attention to this point, r always varies. So r is a distance from the origin to the point. Now this r is from 0, and value of this curve, right, whatever points you get this, so this is p, this is p, any point on this curve will be of the form r comma theta with respect to this radial vector and theta, this angle. So it is moving from 0, then 10, 20, 30, 40, 50, 60, 70, 80 and 90, right? So how do you calculate this? See here, what is this curve? This curve should be expressed in terms of r. So what is this x square plus y square? It is r square, right, which is equal to a square. this square and this square gets cancelled, so the value of r is a. So how it is ranging? The value of ranging is always it is a distance from the origin to the point. So whatever points you have, it will be always a. So value of r will always vary from 0 to a. Therefore my new integral will be with respect to change in limits will be, see here, what is the value of y? Y is r sin theta. Here you can see, so I am writing r sin theta. Fine. Then what is my value of square root of x square plus y square? It is r square, so that square root sign and r square gets cancelled. That is the reason I am writing r. Okay, now what is dx dy? So dx dy, I have already explained you how what is the value of dx dy. I am going to express dx dy in terms of, that is r d theta dr. Okay, now what is happening to the value of r? So as I said that r it is the distance from the origin to the point, so r varies from r is equal to 0 to a. Now what order you will follow, right? So let us say, and theta varies from 0 to pi by 2. Therefore integral over theta to that is 0 to pi by 2, and r over 0 to a. See, this is sin theta, this is r, this is r, this is r, so it becomes r cube. Now see what pattern you are going to follow up. You are going to integrate the given integral with respect to r first, and then theta first, and then theta. Now integration over 0 to pi by 2, sin theta is constant, so r power 4 divided by 4 into, that is over the limit 0 to a d theta, which is equal to a power 4, right? So upper limit minus lower limit turns out to be 0, so I do not include it. So a by 4 is a constant, a power 4 divided by 4 is a constant, and then I take integration over the limit, that is 0 to pi by 2 sin theta d theta, right? Now what is integration of sin theta? It is minus cos theta over the interval, that is 0 to over the limiting points, that is 0 to pi by 2. So a power 4 divided by 4, so after evaluating for its upper and lower integral, so this turns out to be 1, which is equal to a power 4, and that turns out to be your answer. Fine. So see here, again I will explain this. So what are we trying to do? So the given question is, that is evaluate by changing into polar coordinates. So given terms are in terms of f x y, and I need to change in terms of r theta. So what is the strategy? You know that polar, and that is Cartesian coordinate, can be transformed into a polar coordinate. In what sense? Taking x equal to r cos theta and y is equal to r sin theta, and its Jacobian is r. So one set of coordinate points can be transformed into another set of coordinate points. So then the first thing is, take all the points, limiting points of x variables, and draw a rough sketch. And depending upon this rough sketch, you can easily identify, so what is your value of theta varies from what to what values, and see that you should only focus on the, that is I forgot the appropriate word, that is shaded region, right? So this is the shaded region with respect to this limiting points. So theta varies from 0 to pi by 2, and r varies from, so r is a distance from origin to any given point on the given curve, so you have converting it into in terms of r theta. If the curve is in terms of x and y, then you change it in terms of r theta. So r ranges from 0 to a. So this is the simplification I have been done for you, right here, rough. Okay, fine. So let us move on to the next problem. Okay, fine. So the next problem is okay, in the next problem I will be giving this for you for homework, and please verify your answer at any instant. A few of the students also come with doubts, which is appreciated, right? So please check out for this solution. You can do it, and I'm confident about you people, right? Okay, fine. My next question is yeah, so my next question is, so evaluate this given integral to by using, that is and transform it into polar coordinate, right? So the given integral function is in terms of xy, so x square plus y square, right? And the given limiting values is 0 to square root of 2x minus x square, and 0 to 2. Now let me consider this equation. I rewrite it again, right? So dx dy. So see here, So this will be in terms of, that is y is equal to, and this is in terms of y is equal to, and this is in terms of x is equal to, and x is equal to 0 to x equal to 2. I need to convert this into transform this into that is change the variable in terms of polar coordinate. So what is the strategy? So let x equal to r cos theta and y is equal to r sin theta, and the Jacobian j, that is the determinant of j, is equal to r. Now the region of integration r is bounded by the curve. So first thing is, let me have a rough sketch. So this is so y is ranging from 0, so y is 0 over here, fine, okay, and y is ranging from, so this is nothing but this equation is of the form x square plus y square is equal to that is 2x. So if you evaluate and take these points, definitely you will have a circle equation, right? And what is happening to this upper half circle, right? If you conclude this, right? Okay, fine. So x is ranging from what? X is ranging from 0 to 2. So x is equal to 0. So here on the y-axis, everywhere here it is 0, and it is at a distance 2. Now see here. Now what did I say? You see, looking towards this rough sketch. So if you take, see, what did I say? So r is so value of r, I can determine it from the origin to any given point, right, on this curve. So what this curve, I can find it later. Now this here, this is a radial vector. Definitely there will be an angle subtended when the r radial vector is moving from this particular direction, right? And this is my common shaded region to which I need to find the area. Now what is happening to the value of theta? See, obviously theta value is ranging from, that is till here. So till this point the curve touches till here, so it is from, that is 0 to pi by 2. So there is, this is what a rough idea I am giving it to you. In examination you can write it in your own words, there is no problem. Now the problem comes for student is that is how to find the value of r. Now see here, see, r value ranges from 0, so you write that is 0 to what? Now I need to convert this curve to what? That is in terms of theta, r is equal to theta. So see here, this equation I am writing here, the given equation. So y is equal to square root of 2x minus x square. So this I can write it as x square plus y square is equal to 2x, which will be my equation 1. But here what is the value of x square plus y square? It is r square. And what is the value of x? X you can write it as, that is r cos theta. So definitely I am writing this here again, yes. So this r and this r square, 1 r get cancelled, so this value of r is 2 cos theta, right? So value of r, see here, value of theta ranges from 0 to pi by 2, and value of r ranges from 0 to 2 cos theta. Now therefore, now the given change of integral will be I is equal to, so r will be ranging from 0 to 2 cos theta, and theta will be ranging from 0 to pi by 2, and therefore see here the given equation. So x can be written as, this x can be written as r cos theta, okay, and this x square plus y square can be written as r square. Let me check this, because okay, fine. So here it is, yeah, the question is it is square root of, right, square root of x square plus r square, and then this turns out to be what? That is r. Now this r, okay, this r and this r gets cancelled, so you are left out with cos theta r d theta by dr. Now if I integrate, now see here, this r and this r you should evaluate first, that is this equation. So cos theta I will take it outside, so it becomes r square divided by 2 over the integral 0 to 2 cos theta into d theta, right? Now this 1 by 2 I am taking it outside, so after evaluating it, that is upper limit is 2 cos theta, so this turns out to be, that is 2 cos theta the whole square, right? And lower limit is 0, so if I substitute it for 0, so this turns out to be 0. Therefore the value will be cos theta, and this is 2 cos theta square, right? Now see here, which is equal to 2, right? It is this 2 square, here it becomes, okay, fine. So this 2 I will square this, because here it is square root sign, power 2, so it becomes 4, right? So if I take 4 and this 2, if I divide it by 2, so this becomes 2, and that is the reason here there is 2, fine. And by laws of indices this becomes cos cube 3t. Now what you are going to do, you should not keep on evaluating this. I have given certain reduction formula for you, right? So by the reduction formula, and see this, if at any instant if this is pi by 2, please do not include this, because for reduction formula it is always the integral from 0 to pi by 2. This you should keep in mind first, right? So it is 0 to pi by 2 cos cube theta d theta. So reduction formula, after evaluating it, so you will get this particular output. So please try it with reduction formula, right? 2 into 2, 2 by 3. So see here, this here n is what? N is equal to 3, so it is odd. So let me go, because okay, now since n is equal to 3, the other day some person, those who have missed the class in the earlier section, so for them what I will do is I will tell you that where is my, that is reduction formula, where I have given, yeah, see here, this was it. So this is the reduction formula which I was discussing, okay? Any standard integral of the form 0 to pi by 2 and sine power n, right? And cos power n. Now it was cos n 0 to pi by 2 and n is odd. See here, outside it was 2, okay, fine. So see here, so what is the value of n? See here, it is 3 minus 1, and here it is 3 minus 3. So please do not include that. Many of our students, what they do, they start evaluating this, so you don't involve this, right? Finally, when you should stop your answer, see 3 minus 2, yes, it is 2, right? So you write that is 2 over here, fine. And see, this is 3, n is equal to 3, okay, n is equal to if you take 3 minus 2, it becomes 1, so 3 into 1. N is equal to 3 minus 4, so do not take negative part. So always stop your answer when you take the value for n is equal to, that is odd, and when you reach till this particular value, please stop the answer. So it is 2 by 3. In fact, if it is 4, if it is 5, so 5 minus 1, it becomes what? 5 minus 1, it is 4, then 5 minus 3, it is 2, right? And 5 minus 5, it is 0, so don't take it, right? And here it is 5, so divided by, it will become, see, this is 5 into, then 5 minus 2, it is 3. See, here it is, every time when you evaluate it, always you will get 2 by 3. When you get 2 by 3, please stop. And this is the general thing which I had given you, right? So coming back to the problem, right? So it is 2 into, that is 4, so total answer will be 4 by 3, right? Okay, let me go back to my problem and tell you. No. Yes. So see here, it is 2 into 2 by 3, which turns out to be 4 by 3. Yeah. Okay. Now the next problem is, see here, here for this problem, you need not change it. Okay, the next problem is, see, I have an observation, so it is in, this is an example, they have not told you to evaluate. Okay, please read the question properly. So this time there is no conversion at all, because here you have pi, which is in terms of theta, and r, this will be obviously in terms of r is equal to, and this will be in terms of theta is ranging from, that is 0 to pi. Okay, so first thing is 0 to a, so obviously I will, this is in terms of r is equal to, so I will take which integral to evaluate first with respect to dr, right? So So therefore sine theta and cos 2 theta. So this I can write it as over here, that is 2 sine theta, and adjust 2 here, right? So 2 sine theta cos theta, I can write it as sine 2 theta, 2 here, right? If I take this 2 outside, it becomes 8, and minus cos 2 theta, right? So integration of sine 2 theta is minus cos 2 theta divided by 2 over the interval, that is 0 to pi. After simplification, that turns out to be 0, right? Okay, fine. So let us have one more problem. So as I said, you should also know some standard figures, or in mathematics mainly, that is what is sphere, then slope intercept form, then what is a cardioid, asteroid, right? Okay, fine. So change to polar and evaluate, and this time the double integral is given over the region R, and you do not know, and the region of R is also given over one loop. So this time what they have asked you to actually only one loop of Lemnisnate. Okay, so and that is x square plus y square, the whole square, and that is whole power 2, which is equal to x square minus y square, right? Now let x equal to r cos theta, y is because you need to change it in terms of polar coordinate, right? Now x equal to r cos theta, and y is equal to r sin theta, and j is equal to r. Now you do not know what is theta and what is r. So what you do is, and this time only this particular equation is given, so you can easily find the value of r. Okay, and so what I do is, I first write we have, that is x square plus y square power 2, which is equal to x square minus y square. Now r square power 2, that is x square plus y square is r square, and x square minus, that is r square cos square theta minus r square sin square theta. So this r power 4, this is r square, so this r square and this one power, that is square, get cancelled, so it is r cos 2 theta, or it can be written as r is equal to square root of cos theta. Till here you have come to your conclusion. Now see here, now depending upon the value of theta, okay, now this rough sketch is being drawn either by making use of this, or by making use of this. So what did I say, that r is always a value that it is always a distance, that is from origin to any that is any point. Now depending upon this theta, suppose you do not know this word also, right, and you only just assume that this is for your understanding purpose only, okay, but this, because I have already drawn this, suppose you do not know this, okay, and you are into an exam center, so what you do are, so different values of theta, you take this complete coordinate, that is with respect to theta, that 90, 180, 270, and till pi, one complete cycle, right? And then what you do for different values of theta is start plotting the graph. Now see here, I will explain you how does it go. Here, see here, so this is Lemnisnate of Bernoulli. So usually the given equation is always given by this particular equation, so it is r square is equal to a square cos 2 theta, but in our case it is r is equal to, wherein a is 1, so it is given as square root of cos 2 theta. Okay, but I will explain you with respect to this standard equation of Lemnisnate of Bernoulli. Now how to plot this? See here, for different values of theta, see here, 0, it is 1 over here, right? This is 1 pi by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4, 5 pi by 4, 6 pi by 4, 7 pi by 4, 8 pi by 4, because this 4 ones are 4, that is 4 twos are, so it becomes 2 pi. Okay, so it is tracing all the points, okay, with respect to the rotation of theta and r. Okay, now see here, in some few textbook this will be given as 0, pi by 4, pi by 2, because here it gets cancelled, 2 ones are 2 twos are, 4 ones are 4 ones are, that is 1, so it becomes pi. So this is 2 2s are 2 3s are, so it is 3 pi by 2, and then it is pi, right? So this is the reason I have given both the things, so that you should not get confused. So this value is different, this value is different. Now see here how to plot a rough sketch for this also. See what is the value of theta. Okay, so theta, since theta increases, so what is happening, theta increases. Okay, so I'll go to the graph. Okay, so first take the value of theta as 0. So here my angle, here it is, theta is 0. Okay, okay, then what is the value of a, and that is a square. See, if you substitute the value of theta here over, and if theta is substituted 0, then this turns out to be e square, so value is a square. Therefore value of r is equal to what, r square is equal to a square, which is a. So since theta is 0, therefore value of r will be at a distance a. Now okay, so theta increases from 0 to pi by 4. Okay, so 0 to pi by 4, so pi by 4 is nothing but it is 45 degrees, right? Okay, so here it is pi by 4, but what is happening to, that is, since theta increases from 0 to pi by 4, now if I am rotating this angle like this, so obviously this theta is tracing all these values of r, because this is a curve. Okay, so what is happening for r square decreases from a square to 0, because when you substitute pi by 4 over here, okay, so this obviously turns out to be, that is 0, right? Now it so happens that, okay, see here, if you substitute the value of pi by 4 here, so if you take pi by, sorry, here pi by 4, right? So 2 ones are 2 2s are, so cos of 90 degrees is, that is 0, right? So this is 0, so r square decreases from a square to 0. So see here, r square decreases from a square a to, that is 0 here. Okay, and then but as theta increases from pi by 4 to 2 pi by 4, right? So when it is increased from that is pi by 4 to pi by 2, this is 2 ones are 2 2s are, right? So I am writing pi by 2, so r square becomes negative, right? So when you substitute here for the values, okay, so it turns out to be -1, so it becomes minus a square, right? So it becomes negative, so which is not possible, your radius, right? It is not negative. Okay, similarly when you come from, that is pi by 2, it is negative. Okay, and then 3 pi by 2, obviously it is 0 over here, and then again it traces out. Okay, so here it is not possible, here it is not possible, right? Because now see here, 7 pi by 4, I hope it is 315, so 0 to a square. So here what is happening to 7 pi by 4, so it is some, this is minus 45 degrees you can take here, right? So from 0, r is ranging from what, r is equal to 0, and then again it is increasing to a square. I am only interested in this loop, or you if you want, if you are interested, you can be interested in this loop, right? So I am only interested in this loop. This is how it goes, right? So let me come back to my concept. Okay, so it is r is equal to square root of cos 2 theta. Therefore value of, therefore theta lies from what, I am taking only this one loop, so theta is equal to minus pi by 4 to theta is equal to pi by 4. Now therefore my r value ranges from 0 to, that is this curve, this complete curve, right? So it is square root of cos 2 theta, because I am only taking one loop, so 1 divided by, so it is this equation x square plus y square is r square, and here the equation here should be, here it should be square, please make the correction. Okay, and then this is 1 plus r square square r dr d theta. So what I do is I make certain substitution over here. I will take 1 plus r square is equal to t, therefore r is equal to r dr is equal to 1 by 2 dt. Now see here, if I now I need to change the limit also, because I am substituting it for t. When r is equal to 0, what will happen to t? It will turn out to be 1, right? Because here if it turns out to be 0, then t is equal to 1. Fine. Okay, Now when r is equal to square root of cos 2 theta, then square root of cos 2 theta, then it turns out to be 1 plus I hope it is 1 plus cos 2 theta here, right? Okay, now the new limits are, that is pi by that is 0 to 1 plus cos 2 theta, and see here, so this is 1 divided by 1 plus r square. So 1 plus r square is nothing but I have changed it to, that is 1 plus r square is t square, okay, and into 1 by 2 dt. See, 1 by 2 I am taking it outside, right? Now this t square, okay, t square I can write it as minus 2 and integrate it. So it will give me what? It will give me t power minus 2 plus 1 is minus 1 divided by minus 1. This minus sign I will take it outside here, right? So this t raised to minus 1 I can write it as 1 divided by t. Is it right? Okay, so I have written 1 divided by t. But what is your t, right? In fact, my 1 by t is, that is 1 plus cos 2t. Fine. Okay, now, okay, and this is minus 1. Okay, now we have evaluated for this also. Okay, fine, sorry, I take my words back. So see here, this is upper limit, okay, and lower limit. So 1 divided by t square is 1 divided by 1 plus cos 2t minus, so lower limit cos of this is 0, okay, cos of 2 theta. So upper limit minus just a minute, just okay, no, here actually the value should be I haven't written because it is 0 to that is I am changing, no, t, I have written this as it is, it should be 1. Please make correction. Yeah, so 1 upon t square, so this turns out to be after integrating it I will get 1 by t. So 1 by t, and this minus sign is here, so it is 1 plus cos 2t, that is my upper limit, and this is my lower limit, that is for 1. If I substitute 1 here, it turns out to be 1, right? Now see here, what do you have a formula, that is 1 plus cos 2 theta is equal to that is 2, my writing pad is not working properly, so kindly bear me, cos square theta. So if I write in the numerator 2 cos square theta, so this will be 1 divided by 2. So 1 by cos, it turns out to be sec square theta minus 1, right? And integration over minus pi by 4 to pi by 4. Now see here, now this minus 1 by 2 into 2 times, that is 0 to pi by 4. Suppose if you have any limit minus a to a and f of x and dx, you can write it as 2 times 0 to a f of x and dx, right? This is our property. So this is 1 by 2 sec square theta minus 1. So this 1 by 2, right, and this again it gets cancelled over here, so again it is minus 1 by 2. So tan theta, so sec square theta is tan theta, 1 is theta, 0 to pi by 4, so your answer is, that is pi by 4, right? And this turns out to be a output. Okay, now the next example is, that is evaluate by changing into polar coordinates. So the question is given like this, fine, and this problem is over here. So it is given as x square minus y square divided by x square plus y square dx dy over that is the limits, that is y square divided by 4a and y 0 to 4a. So obviously, okay, let me write the solution. So let my solution be, that is I is equal to this given region and x, right? So the region of integration is, so y is equal to 0 and y is equal to 4a, then y is equal to that is the curve y square is equal to 4a and x equal to y. So obviously this, you know, that is x equal to y is always a 45 degree, that is equation of a line. okay, at 45 degrees. So half of your job is over. So one of the value of theta you have come to know. This is I have not yet drawn. This is already I have drawn this and given in your notes. But first thing is you need to write the draw this coordinate and then draw this theta. Now this is x is equal to y square is equal to 4a. So you can write this in terms of, that is, y is equal to y square is equal to 4ax, right? So y square is equal to 4ax is what? It is an parabola which is opening towards, that is, right. This is my right side, so it is opening towards right. Okay, fine. So this is a parabola like this. Complete you draw now, but I am interested in only the region bounded by the curves. So this is my area of interest to which I want to find the area, right? Now if I put, okay, I need to have what, that is now if I put x equal to r cos theta, y is equal to r sin theta in. So see here, my one of my value of theta is what? It is pi by 4. So theta is ranging from, that is not from 0 this time, it is ranging from pi by 4. See here, so it is pi by 4, okay, until where it is reaching, it also depends upon r. Now my r is what? R is it is a distance from the origin to the point. So my r, if I draw a radial vector over here to this point, so it is what? It is okay. And this when evaluating for y is equal to x and y square is equal to 4x, the point of intersection will be 4a. So one of the value of, that is r will be 0 to, that is from here 4a. I also, but this is a curve, right? So here this is a point, this is a point, this is a point. Here also that is r, here it is r, here it is r, everywhere it is r. So now what is happening to the value of theta and r? So theta value is, sorry, I will write it once more so that there is no hurry. Okay, so here theta value ranges from, that is, pi by 4 to, that is, here it is 90 degrees, because your r value also r, that is point from the origin, that is distance from the origin till any point. It might be this point, this point, this point. Here it is 90 degrees, so it will range from, that is, pi by 2. So theta value is over. Now what I will do is, because since my point r is traced on this curve, so what I will do is I will take this curve and evaluate it for the value of, that is, general value of, that is, r. So let's see and bring it in terms of r is equal to f theta. See, this is in terms of y is equal to f of x. Okay, so I will do it in terms of r is equal to theta, so that I can have a value of a. Okay, so this is y square is equal to r square sin square theta, which is equal to 4a r cos theta. So r is equal to 4a cos theta divided by sin square theta. Now here what will happen? Now theta varies from pi by 4 to pi by 2. So seeing this rough sketch, it is easily seen that theta is varying from, that is, pi by 4 to, that is, pi by 2, right? And then what is happening to r? R varies from 0 to 4a, that is this value, 4a cos theta divided by sin square theta. Now therefore the new integral will be, that is, after changing the variables to polar coordinates, so r is equal to 0 to 4a cos theta sin square theta, and theta is pi by 4 to pi by 2. Now see here, so this r square and this r square I will take common, so this r square, if I take common, then it gets cancelled, right? Okay, and this is r, so this will be my constant, and this is r. See, this, the chronology or the order should be dr with respect to dr. So if I take r square divided by, so after integrating, this is a constant after integrating with respect to r, and over the limit, that is 0 to 4a cos theta by sin square theta, right? So this turns out to be 4, it is square, so it becomes 16. This is a, it becomes square, so cos square theta divided by, so here already it is 2 sin power 4 theta, and this is cos square theta minus sin square theta. Now what I'll do is, so here 2 ones are 2, 8 is 16, so 8a square I will take it outside, and this is pi by 4 to pi by 2. Now see here, this 8a square I am taking outside. Now this cos square, okay, this cos square and this cos square, it turns out to be cos power that is cos power 4 theta divided by sin power, this whole term I will multiply here inside, it's sin power 4 theta. So cos theta by 4 theta, it turns out to be, that is cot power 4 theta. Fine. Minus, now here again I multiply this here, okay, so it is cos square theta sin square theta, so sin square theta and divided by this, so cos square theta divided by sin square theta, I will get cot square theta. If I take common from this, so it is cot square theta into cot square theta minus 1 d theta. So this is 8a square over the limit pi by 4 to pi by 2 cot square theta. So this is cot square theta can be written as cosec square theta. This is minus 1, cosec square theta minus 1, and this is minus 1. So this minus 1 and minus 1, it becomes 2. Now here I have written the solution in a much more precise manner, but I want you to explain it so that each and every student can understand it more comfortably. So you can pause the video and capture this also, right? So what I'll do is, I have again rewritten this, okay, so see here, sorry, yeah, so this equation, this is 2 over here, right? So what I'll do, I will take this, then again what I'll do is, I will multiply this here, so it becomes cot square theta into cosec square theta. So this is here minus, so this minus sign from here I will take outside, and here it will be 2, so 2 also I will take outside and I'll multiply over here, so it is cot square theta. So thereafter, okay, so this will be your equation. Fine. Now when this is your equation, this is your equation, so I will take this as I1, okay, I1 I2. Now I1 is equal to pi by 4 to pi by 2, so if I take substitution, cot theta is equal to t, therefore it is minus cosec square theta d theta dt. Now this turns out to be, that is again if I substitute, that is again, sorry, let me think, it's not working. Okay, my marker is not working. Yeah, now it is, yeah, fine. So this is I1 and this is my I2. First I will evaluate this, and see here it turns out to be pi by 4. So if I apply pi by 4, so cot of pi by 4 is what? It is 1. And if I take cot of 90 degrees, it turns out to be 0. This minus sign, it is here. So see here, by one of the property, if you change the order of this limit, that is from 0 to 1, then this minus and that minus get cancelled, so it becomes plus, right? So it is t square, then then integrating it, that is t cube divided by 3, that is 0 to 1, right? So here I have written the limits. When theta is equal to pi by 4, it is t is equal to 1, and when theta is equal to pi by 2, it is equal to 0. Now here I2 is equal to 2, integration from, that is pi by 4 to pi by 2, and it is cosec square theta minus 1 d theta. So here it turns out to be 2, integration from, that is, sorry, over the limit, the cosec square theta is minus cot theta minus theta over the limit pi by 4 to pi by 2. Okay, so minus, if I take outside, it becomes cot theta plus theta pi by 4 to pi by 2 minus 2. This is upper limit minus lower limit. So on simplification, so if you do the simplification till here also, it is okay. So and the rest part is easy, and this will be your answer, right? Okay, now let us move on to the next problem. I hope this problem is understood, right? Yeah, so this description, that is information I have given, that how to transform variables by using Jacobian, right, in my earlier section, that is here it was. So all these problems have been done. Okay, yeah, I've been telling you that if x and y, right, all these things I have explained. This is x and y, u and v. So if x is expressed in terms of u and v, and y is expressed in terms of u and v, then the Jacobian, then the transformation of x to v, right? Let me write it: x, y, u, v, wherein the Jacobian is not equal to 0. So this is the given region R, dx dy. This is your Jacobian, okay, whatever is the value, that is j, okay, and du by dv, and this according to the limit of this, we are also going to change the limit of this, right? So yeah, so this is the, again, same thing I have written, how to change. This is the definition which I have written, but here it is in terms of u and x, right? Okay, let me go directly to the problem, right? So here what is said, applying transformation, what I need to do is, so the given equation is x plus y is equal to u and y is equal to uv. So x is expressed in terms of u and y is expressed in terms of uv, and show that the given integral, that is from 0 to 1 and 0 to 1 minus x e power y x plus y dy dx. So I need to express this given integral, that is f of xy, in terms of a new variable, that is f of u and v, right? Okay, fine. Now yeah, so see here, given is x plus y is equal to u and y is equal to uv, and Jacobian j I can, because since I need to transform this x to v, so this is the Jacobian, and let me consider this as equation 1. Now since u is equal to x plus y is equal to u, and that is so I can write it as u is equal to x plus u v, because the value of y is uv. Therefore x is equal to u minus uv, which is equal to u in the bracket. I am taking this u common outside, so 1 minus v, this is my equation 2, and y is equal to uv, right? Now this is my equation 3. So what I do is, I want the values of this, and this. So do x by do u, so differentiating partially, that is with x with respect to u, so this is 1 minus v, okay. Then do x by do v, it is minus u, with respect to v it is, right? And here, so it is this is 0, this is that is 1, and this becomes minus v. Similarly do y by do u, it is v, do y by do v, it is equal to u, right? So collecting all these value and substituting in equation 1, that is for this, right? So 1 minus v minus u v, so take the determinant of this, okay. So this turns out to be u, right? Okay, now what you do is, I need to transform. First thing is, in your mind you should have a rough sketch, right? So you should know how to draw a rough sketch first, right? So what I'll do is, see here it is 0 to 1 minus x and 0 to 1. Obviously this value will be y is equal to, and this value will be x equal to, right? So first thing is x equal to 0 to 1, so obviously x is 0 comma 0, and here it is 1 comma 0, and y is ranging from, so see, value of y is what, y is equal to, I hope it is 1 minus x. So if I take this value this side, so it becomes x plus y equal to 1, which is nothing but, it is 1 here, it is 1 here, which is nothing but a slope intercept form. And that is the reason I always keep on telling you that please have a rough idea about the figures, standard figures, right? Okay, now see here the value of x is equal to 0, sorry, yeah, 0. Here the value of y is equal to 0, and this is the equation of the line, that is x plus y is equal to 1. Now see here, I need to transform this geometry into some other geometry or some other value. Okay, that is u I have to express, that is I am changing my variable. Now u is equal to xy and y is equal to uv. So I can express this x plus uv, this is nothing but my y, which is equal to u. So x I can write it in this particular manner. Fine. Okay, now see here, what will happen for x equal to 0, for this particular line, what will happen for x equal to 0? So u in the bracket 1 minus 1 v is equal to 0, which will have two roots, that is one is u is equal to 0 and v is equal to 1, right? Fine. Okay, v is equal to 1. Then for y is equal to 0, for this particular equation, uv is equal to 0, therefore u is equal to 0, v is equal to 0. Okay, so obviously, so for this particular thing, okay, so x equal to 0 and v is equal to 1. So see here, v is at a distance, what it is at a distance, that is from here to here, it is at a distance, that is v is equal to 1, right? Now x plus y, this slope intercept from this line, what will happen to this line, this particular line? Okay, x plus y is equal to 1. So what is x plus y? In fact, x plus y is u. So u is equal to 1. So u is also, it is 0 and u is at a distance 1. So this line transforms in this particular manner, that is u is at a distance 1 and u is equal to 0, v is equal to 0 and v is at a distance 1, right? Okay, now see here, now therefore given integral, so this is the new integral with respect to, that is Jacobian du dv, and what I do is, so my new integral will be, so it is need not necessarily you write this, if you want you can write, so directly write I is equal to, with new integral, that is over the region R, e raised to uv by v, because here it is y value is uv, x plus y is u, right? And then this u and this u gets cancelled, where it is e raised to v u du dv. Now it is over the intervals, that is new limits will be 0 to 1, 0 to 1. So what I'll do is I will take du first. So if I integrate with respect to u, it is u square divided by 2 over the interval 0 to 1 dv. So after evaluating this, you get, that is u square, it is 1 by 2, this 0, so I did not calculate it. So e raised to v over with respect to dv, if you integrate it, so it is e raised to v only over the limit, that is 0 to 1, and finally you will have the answer, that is 1 by 2 e power 1 or e minus 1, and that turns out to be a answer, right? Okay, now my next topic is typical, that is triple integral, which I will do it in my lecture 4. So students, you people are required to practice since you have ample time, and please stay safe at home, and that is my kind and humble request. For triple integration, by the time you complete your lecture 3, and at any instant if you have any doubt, please let me know. Yeah, okay, thank you very much.